Question 1 of the Optical Phenomenon worksheet, which is Photoelectric Effect, and it's taken from the Gauteng prelim exam, essentially from 2008. So, the sketch below shows the components of a photocell used in a camera light meter. So, photocell just means that we get electric current from by electrons being ejected from a photon, okay? Then they say to us the photocell consists of a cesium cathode. There we go. So cesium is the metal we're using with a small work function, which means it doesn't take a lot of energy for the electrons to be moved off. When monochromatic red light, now the monochromatic red light means that it is light of a single frequency. It's not a combination of red, it's a single red light. From a 50-watt bulb that tells me the brightness, the intensity, strikes the cathode. The light meter reads a small current, so in other words, there's enough energy from the photons for current to come off. Then they say, what is the name given to the effect described? It's the photoelectric effect. Nice and simple. Then they ask you, what will the effect on the current be? What will the effect on the current be? What will, ignore the very bad grammar, when the 50-watt bulb is replaced by a 100-watt bulb. So what we've done is we've increased the brightness. By making it brighter, we will have more electrons emitted per second, so the current will increase. So what's the effect? It increases. Okay? Why? The light is more intense, therefore more electrons will be emitted. Now be careful, you're going to forget something very important here. Emitted per second. Okay, don't forget the per second because we're looking at current. Current is about the rate of flow of charge, so it's got to be per second. Then, what will be the effect on the kinetic energy of the emitted photoelectrons if the 50-watt red light is replaced by blue light? Okay, so now we've got to decide whether we are increasing the frequency or not. So by going from red to blue, we're changing frequency. Now, the colors of the rainbow are red, orange, yellow, green, blue, indigo, violet. Now, I remember this in that infrared comes before red, ultraviolet comes before blue, after the violet, and ultraviolet has a bigger frequency than infrared. So, by going from red to blue, we're increasing the frequency. If we increase the frequency, the light has more energy. And if the light has more energy, then the kinetic energy will be greater. So why? So first of all, what happens? It increases. Okay? Blue light has a greater frequency than red light. Okay. Therefore, the energy of blue light is greater than the energy of red light. Okay. Very straightforward. Now they say, ultraviolet lamps are often used in butcheries even though they are potentially harmful. One of the reasons why they use them is to kill bacteria. Okay, that's why it's used. A photon of ultraviolet light carrying 2,95 times 10 to the minus 20 joules of energy shone onto a metal with a work function of 1 times 10 to the minus 20. They want the speed of the ejected photoelectron. So what are they telling you? They're telling you that E is 2,95 times 10 to the minus 20 joules. They then tell you that the work function WO is 1 times 10 to the minus 20 joules. And they want velocity. So, we have an equation that says to us that E is WO plus EK max. Okay? I know E, 2,95 times 10 to the minus 20. I know WO, 1 times 10 to the minus 20. EK is going to be a half mv squared. I'm going to take the 1 times 10 to the minus 20 over, so I minus on both sides, so I get 1,95 times 10 to the minus 20 is going to be equal to a half. Now the mass of an electron is not something you're expected to know. It's on your information sheet. 9,11 times 10 to the minus 31, it's very tiny, v squared. Okay, so now you would times by 2 on both sides, divide by 9,11 times 10 to the minus 31. Once you've got that answer, you square root your answer. Don't forget to square root it. And what we get is 2,07 times 10 to the 5 meters per second. And I'm happy with that number. I haven't exceeded the speed of light. As soon as you go bigger than 3 times 10 to the 8, you've absolutely made a mistake. But it is very, very large. And I expect that because I'm looking at very, very tiny particles that are moving. First question, done.